Okay. All right, so today I think I will talk through 2.3 intro to large language model reasoning, and hopefully I can finish 2.3 and 2.4, including both the reasoning part and also inference time thing. Let's go through it quickly then. With large language model reasoning, I think everyone heard about reasoning starting from DeepSeek R1 when early about in January this year, like it gets really crazy and getting so popular. And the way they actually introduced it was implement a keyword says weight. So basically it asking itself to actually evaluate what the answer or like generated answer, whether the generated answer are okay or not, and then continue. So let's go through this notebook. Everyone should be familiar with this Nebius API key already, and we are using a Llama 8B model. Then what is the reasoning? Let's say if we're using an instruct model, even though it's like a big instruct model, if you ask it what it is, it will tell you what it is. It's a little bit like question and answer, that kind of things. But if you're asking it to actually to give you or to ask you to solve a question, like a math question, what it does is, oh, sorry, I don't have anyone here, so I need to. Yeah, so what it does is like it gives you a full solution. If we're asking it, okay, solve this math equation, and if it does it, it is this is actually a math equation which is tropical geometry, which the multiply is not multiply and the plus is not plus, something like that. So yeah, then this was the way to actually do large language model back in 2023, 2024, the majority are actually doing this way to do an instruct model. But the thing is, at that time, large language model is not always reliable, and regardless of the hallucination, like when it gets to a complicated problems, it doesn't actually give you, like sometimes it just tell you what it is, and then without an answering, without actually a reason why it is doing. So there is this need to know the process of this, how large language model generate this solution. And also another thing which happened was at that time, when this problem is so complicated, it is researchers find out it's really hard for large language model to figure out what to do. So it wants the large language model to split the task into small steps. So what do you want to do the first step? And then after this first step, like one prompt saying that, okay, what is the first step? And then with the first step, what are you going to do next, or what are you going to do within this step? So split a big task into many small tasks. This is what we considered as chain of thought at that time. And this is how we actually started talking about the reasoning, because we start to see the steps in each starts to see in each process. So that is considered, oh, this is what the thought process is produced, and that's why people are considering as a reasoning. Then it doesn't always work very well. Large language model, even nowadays, you can't actually ask it to generate what you want it to generate. Like recently, I was trying to build a translator app, and without proper prompt, I realized that it actually doesn't give me what I want specifically, unless I code it myself. I can't just do a vibe coding within the prompt saying that, okay, you generate me that. So basically, That's why we need this. We developed something, or not we, like the people who works in this design something like tree of thought and graph of thoughts. So what happens is you can ask the large language model to give you several answers, and then you figure out what is the best answer. And then if we are having splitting a complex task into so many smaller tasks, we can ask it to generate the first step. From the first step, we generate the second step, third step, and then it will be looking like a tree. And also with the graph of thought, it's like, okay, the first step might go to the second different step. So we combine, like either we direct to a different route, or we combine it to with some other generated solution, and eventually give an output. So it will be discussed more in 2.4. So this is what the tree of thought and graph of thought. You can see that we have input, and we generate the first step and then go to the second step. And sometimes, if it's not doing so well, we even ask it to question itself. We will discuss it in a later stage. So basically what it says is, okay, are you right? The first step was I correct in the first steps? Can you improve my first step so we can refine it, or just question itself? Something like, imagine DeepSeek give you a keyword, which is wait. At some point, it says, wait, let's reconsider. Wait, do we need to generate a few solutions and see which one works? Or at this second layer, we can say, okay, wait, which one is actually a better result, or better step, or the process. This is something called process reward model. So we will talk about it probably in a later stage in this page or the next page, which is talking about how we actually reward the machine learning model to prune it, to tune it to the preferred direction we want to have. So let's see some examples. We are asking it, my binary classifier got a recall of 0.8 on a data set with a balanced class. And what could be the minimum and maximum precision? It gives us the way. We have a given assumption. This is a breakdown of a big problem, because consider it as a big problem. How do we split them into define the problem, find out what the parameters are, under what kind of assumption, how do we evaluate it? So so on and so on, and how do we calculate it? So this is considered as a way of chain of thought. So when it comes to if you look at it, it's a little bit like given, recall equal, balanced classes equal, assumptions. This is what the assumptions are. But when we compare it to something like a different model, to understand this problem, we need to recall the definition of, it's a little bit like telling you or teaching you what to do. When we go to DeepSeek R1, okay, let me try to work through this. First, I need to do that. Precision, total instance is about 200. Now we need to do this. Then, but how does FP related, the false positive related to the other variable here? It is asking itself a question now. So this is a reasoning. So this is a reasoning model. What a reasoning model giving you? So the first one is a very typical chain of thought. Break a big task into smaller ones and start giving you each step. And DeepSeek R1 is a reasoning model because you can see, okay, wait, alternatively. Thinking about it as this kind of a tree root, it's like, oh, alternatively, I could go that way, I could go that way. So there are so many ways. And wait, look at myself. Am I correct in this step? Do I need to go back into the last layer? So this is the difference between the reasoning and the non-reasoning part. But reasoning is kind of I won't say it's very different from the thought, because it's still a way of thought. Instead of doing chain of thought, it started to build a much larger graph of it. If we look back into this figure, let's say, so chain of thought, what it could be done is like input and first step, second step, third step, fourth step. This is the chain of thought. But the reasoning would be tree of thought and the graph of thought. You need to go through all of them to find out the best answer. That's why sometimes reasoning is giving us a better result. But at the same time, it costs you so much more. Okay. Now, over here, I think what has been done is, yeah, so these are the nonlinear reasoning models. So we have the O1, O3. Basically, the whole OpenAI's O series are reasoning, and the cloud is a reasoning one. Gemini 1.5 and 2 are reasoning. Grok 3 is reasoning. DeepSeek R1, which we knew, and this is I think it's Gwen. Yes, this is Gwen. QWQ is a reasoning model. Yeah. So empty system prompts. So with the system prompt here, it actually tested different type of system prompt. It doesn't affect much about the result, but it does give you a little bit different tune of wording. Over here, if you say, okay, you are a helpful assistant, the way it tells you is like, oh, we know it. This is a little bit like teaching, a teacher telling you, explaining to you how the whole thing works. And but if we don't run it, it's kind of hardcore instruction. Well, first of all, it's because it's instruct model, so it was tuned to be instructive way. But if you are saying something like your assistant, you are a helpful assistant, the way it talks about things is a little bit different. But eventually, it doesn't actually make much difference to the solution it gives. Feel free to stop me if you have any questions. Like if you want to discuss a certain thing, and if you don't understand some parts, we can totally talk about it. Yeah. So when is reasoning useful? That's a very interesting thing. Because this notebook starts to talk a little bit about reasoning doesn't actually work everywhere. And this notebook was written before Apple published their new paper talking about the reasoning is actually not actually helpful, and people misunderstood what the reasoning are doing, and we think it is thinking, but it's actually not. Yeah. So this is the new paper. Actually, it came out about a few days ago, I think. It talks about the illusion of thinking. It basically, what it discusses is actually, it doesn't think reasoning actually works that well within a large language model. It adds the complexity of the problem. I actually haven't read this paper yet. But this is an interesting topic because similar things was discussed. Similar things was discussed in this notebook already. So yeah, like since we added since this field we have nonlinear reasoning, it starts to actually perform so much better in loads of the benchmark. It talks about the ARC AGI and frontier math, these specific two benchmarks. You can see the solved task within this timeline. You will see when the nonlinear reasoning came out, dramatically increased all the values over here. Like all the, I think that's the top one on the benchmark. For ARC AGI, you can see the solved task goes from just above 30% to 90%. That's dramatic. And when it comes to math, frontier math, yeah, the frontier math was always a difficult one, I remember. It went from like nearly 0 to nearly 30 at this point. So that's why like people are getting crazy with reasoning since it came out and just had this huge leap on the benchmark. So then people start to talk about, okay, do we still do chain of thought then? It is working in complex tasks, especially in math, because when it comes to math, you don't actually, unless you're asking a very simple question, otherwise it needs step by step. So math question is always a very typical example for chain of thought, or for some problems which need to be solved step by step. So over here, it is talking about chain of thought is quite useful in math tasks and tasks involving symbolic computation. It's not useful in tasks that check factual knowledge or involve common sense reasoning. So if it's not something you could think about, like step by step being done, like you need to actually give a few thought, go through a few things, chain of thought doesn't actually work very well. So there are something talking about the downside of chain of thought. But also thinking about like reasoning is a little bit like chain of thought, but it explores all the possibilities. So it is still different. And over here, we're using MMLU benchmark. It is quite commonly used benchmark to evaluate. Oh, this is 2.3. Natalia, do you have access to the GitHub? So this is Nebius AI GitHub. Let me see if I have it. This one. I'll share this GitHub on the chat. So we're going through the 2.3. So yeah, MMLU benchmark is a very commonly used benchmark for evaluating the performance of large language model, and yeah. Yeah, and so when the large language model is prompted to only give the so okay, what we're going to do is we're going to check a few models, 8B, 70B, or going 32B in some high school math and history. So that's kind of two examples about math problem with chain of thought, and something which needs a little bit of thinking or language or text-wise style of task. We are going to ask it to give prompts to only give the answer, or perform a step-by-step reasoning before giving the final answer. Yeah, so keep in mind, reasoning can be quite costly. Depends on how far you will go, especially when the maximum token from the recent large language models are already going to, I think 200-ish or 500K, 600K, something like that. One of the model was like, I remember I saw it like over 600K or 800, maybe not 800, 600K-ish. So have a look of that, because if you use the wrong model, your bank account might be wiped out immediately. That's what happened to me. Like, I was like, oh, I'm going to try a slightly larger model, and I'm going to, I'll be like, I'll just give it a go. Like, I only got £10 on my account. I was like, yeah, that's fine. How bad can it be? After 5 minutes, wiped out. I was like, oh, okay. I need to be very careful with that. Yeah. So just be careful when you actually start to working with these big reasoning models. So this is basically the code to actually do the evaluation. What it does is basically giving for so MMLU is having a lot of questions and answers. So basically giving all these questions, give me an answer, A, B, C, D answers. So that's what it wants to generate. So that's it. If you look at it, MMO, so it's like giving a full choice and ask you to reply with one choice. This is what the code is. This is what is it is asking to generate. So giving the question, if it's not chain of thought, answer will be like, okay, A, B, C, D. And if it's without chain of thought, work out this problem step by step. And if you do well, I'll tip you $200. I tried that technique a little bit. I have to say, with the app I'm trying to build, it doesn't really work very well. But apparently, it's been approved by several people. Like, I don't know if you change it to $500, would it work? Who knows? Haven't tried it yet, but it's fun to try. Yeah, let's look at these numbers. So basically, what it does is for topic high school word history, mode no chain of thought, accuracy is 0.888. Mode with chain of thought, 0.88. Yeah, mode with, so mathematics, no chain of thought, 0.56. Mode with chain of thought is 0.7. So actually, chain of thought works better with math problems, but it doesn't seem to make a dent on the high school word history. So if we change the model, I think before we used 70B instruct, now we use 8B instruct, which is less parameters. Over here, you can see dramatic increase, but it doesn't actually change much over here for the high school word history. And then I tested out Grand 2.5. Grand 2.5, yes. It has a slightly increase on the mathematics with the chain of thought, and not much difference, I'll say, on the word history. So the effective chain of thought is very significant on the high school math, but the high school word history doesn't actually change that much. So this is where we depends on what kind of task. That also means depends on what type of task we want to do. The way to actually use large language model are different. So even though people are trying to build a general purpose large language model, for specific tasks, it's also a very specific model you could choose, and specific design or framework people are generally do. Something like personally, like I really like Cloud as the way to do the coding to generate codes. That works very well with I think with the SWE benchmark. But when it comes to the text generation, I still go to ChatGPT to use their free version. Or if you want to ask for some specific questions, depends on what kind of framework they are building. And if there is specific task you want to build or to solve math problem, you could build a platform which does chain of thought using these models, because we're using the same model, like Gwen. We're using the same Gwen. It's just we're asking it to do a chain of thought or not chain of thought. So this depends on what kind of system prompt or just general prompt you are giving it to. But it doesn't really mean it works like these kind of thought process would help um, in general, because reasoning model, it's like it gets really complicated. If it's a simple problem, it's ask itself to think and rethink and just keep thinking. For example, over here, who is the main character of Miss Bone trilogy? Tr trilogy. I have no idea what that is. It's a very simple answer. It needs a little bit search on the website, or if it has this knowledge, it will just generate an answer, or just give you a little bit paragraph saying, oh, after this type of thing, I think the character is this person. No, it does all that, and then say, wait, consider. I need to rethink. Just keep thinking until I think I get an answer or something. I don't even know where the answer is. It just gets really complicated. So if I ask you to do a very simple math, Jack the Sparrow has 12 sailors and Davy Jones has 125 sailors. And how many sailors in total? That kind of things. They do, okay, first let's see. Oh, first, wait, 12 plus 125. Let's add them. Solve that. No, it doesn't. It just keep thinking and thinking and thinking. Where is the answer? Yep, same thing. 125 plus 10 is 135. Plus 2 is 137. And then it like, I'm glad I know the answer of this. Otherwise, I'll be like, where is the answer? Where is the answer for these simple questions? So that's kind of like the problem is, how do you use different type of model? And like, I won't use a reasoning model to solve a simple task, which I just want to do some agentic AI to search on the website and figure out what happened, or just simple math tasks. I won't use a reasoning model for that. So why reasoning works? Very interestingly, what happened is, so basically this paper, let's reason dot by dot. They substitute part of the reasoning tokens, like I think all large amount of it's, oh, sorry, I didn't see a figure here. Anyway, large amount of reasoning token, sorry, not tokens, large amount reasoning token or embedding, oh, token, sorry, large amount of reasoning token into dots. So instead of having the reasoning part, change everything to dot, like, which basically is nothing. It's like a mask to say, okay, for example, these need to be feed back into the large language model with the thinking process. I'm changing all that into dot. Somehow, it still gives me answer. Sometimes it even work better, actually. Yeah, you would imagine such a stupid dot-minded model. The thinking tokens are all dot. There's nothing inside. It behaves significantly better than the same large language model fine-tuned for giving an immediate answer without reasoning. So how does reasoning works in this case? That's very interesting. That's why I'm also very interested in this paper, which is the Apple's recent paper talking about, does reasoning actually work, or how does it work? In some cases, in some cases, should we just replace everything into dot and then solve the problem? Yeah, so let's run a very naive experiment. In the original paper, the author fine-tuned the model. We just do 8B to output dots instead of the actual reasoning. So we replace everything to dot, then ask it to give an answer. So there is no connection between the number of thoughts and the length of the actual chain of thought solutions. It is actually pointed out that 8B is very, it's a little bit different. So over here, I think, let me see. The answer is A. The model response giving an answer is A, and the model is not correct. Means basically what we are having the dot product is we have the question. The question is coming through here, and we actually see, yeah, instead of reasoning, output dots. Yeah, so this 8B is actually behaving pretty different. I think that's why it is talking about peculiar about this 8B model here. I'm going to stop here and ask if you guys have any questions. Like everyone is happy. Okay. Yeah, I will continue then. Talking about the coconut, the chain of continuous thought. You can see the whole process of the how the research goes is go from the chain of thought and then going through this kind of a different process of a chain of continuous thought, and then go through the tree of thought. Many researchers are exploring, different researchers are exploring different areas. So coconut is one of them. What it does is instead of considering we are going to reason in language, see, yeah, we are not going to reason in language. We are going to reason in vector embedding. So instead of the text, a reasoning text you can understand, it's not going to be text anymore. It's just going to be the vectors, just numbers, which you cannot decode. So what happened with that is we are, I hope everyone understand about the large language model, how it's generating the next one, the next token. So we have token in the beginning, we have token at the end, we generate token at the end. Everything in the middle are vectors. We do not understand. We cannot decode them. We do not know how they work. So to be able to generate reasoning text we understood, we need to generate the token at the end, and then we feed it back. So in this case, what it's saying is like it's going to reason in the middle instead of at the end. So what it does is it gets rid of the completion token, corresponds to the reasoning part, and use the last transformer output vector, which is these parts, the gray parts, which is a vector, which hasn't been generated to a token, and use that as input, the new input for the next embedding vector. So this is the reasoning what it is talking about. Apart from that, it would, so this is called latent thoughts because it's a thought, but you don't understand what it is. So this is a latent thought. Before, if we're doing like chain of thought, we have a step 1, step 2, step 3, step 4. So in this case, instead of having step 1, step 2, like a chain of thought, what chain of thought does, it had this kind of latent thought which hasn't been adding to token and put it right back. Oh, was it token? I think this section, it might be token here. Replacing them. Special token. So I think this is probably not token. And just put it back and to replace the step 2. Generate another one, put it back to consider as step 3. So instead of a chain of thought, it's a chain of latent thought. That's how the coconut is from. the name of the coconut is from. So in this case, it's something we would not be able to read, but it will save so much computing time and power. And the results are pretty good as well. So yeah, this is a part with the chain of thought. And the next one is talking about the nonlinear reasoning, talking more about nonlinear reasoning and talking about orchestration, which we have. People. Hello, we are coming to the very end of this, but gladly you catch up with the 2.4. So basically, we're going to talk about this nonlinear reasoning, like basically the tree of reasoning and the graph of reasoning now. So basically, there are like, how do we do these type of reasoning really fast? Chain of the reasoning is limited because you need to generate step 1 and generate step 2 and generate step 3. They are all running one after one after one. Then I don't know if you guys use ChatGPT every day. Today I was running into a problem. ChatGPT was probably having a very heavy traffic today, and they stopped giving me anything because like it's kind of jammed. This is one of the problems that people are trying to solve, because think about the reasoning. They all take like, most of the large language model nowadays takes loads of computing time, especially you think you're actually doing that, calculating the token of your input. It's having incident maybe before O3 Pro release. Okay, that's interesting. That's interesting. I don't know about that. Maybe it's related to O4 Pro release. Are they releasing it today? I don't know about that. I'll have a look. That's interesting. So maybe because of the new model got released and there is this rush of trying out this new model, that makes sense. So one of the thing people are trying out is not trying out, are doing is parallel and sequential orchestration. So what does tryout do? So as we all know, large language model, actually the one you are looking at is actually being fine-tuned and being processed a lot under the hood in the platform. You are getting one answer from this model. Actually, in reality, the platforms are probably generating 10 results and choosing the best one behind, like on the hood, and giving you the best performance one. So that's why you get a pretty good result. What they're doing is that they were doing a parallel best of n. Over here, they generate 8 results, 8 solutions, or 8 responses. Choose the best answer and give it to you. Or they are doing the sequential revision. What is a sequential revision? Think about this weight in the R1, DeepSeek R1 question itself. I'm getting an answer, but I'm not going to give it to the user. I'm going to question myself. Am I correct? Am I correct? What's the alternative way? Am I correct? What's the alternative way? Am I correct? What's the alternative way? It is going to continue doing 8 times and then choose the best among all of them. How do you choose the best answer? That's a very good point. We're going to go through it later. Well, probably not later. I'm going to quickly finish over here and then talk about how to choose the best answer. Then it can be a combination of sequential and parallel. So I'm getting 2 processes in parallel and then comparing the one at the end. So this is what it does. How to actually choose the best answer. There is an evaluation process. Let me see if it's in this one. Maybe it's in 2.5. There is certain type of, let me see, value. No. it is probably discussed in the process reward model. Basically, what we are trying to channels on beam search. Yes, over here. So I'll use this as example to see how do we actually find out what the solutions are like. Generally, we have a training set. People having training set. You have the question, you have the answer, which roughly to be the similar. So, oh, over here, let me see. This is part of it, but one of the method is also use large language model as a judge. This large language model can also be used as the process reward model, which basically is talking about a model to evaluate the score or the accuracy or whatever evaluation matrix they're using to score each process. So imagine we have a chain of thought. We have step 1, step 2, step 3. It evaluates step 1, consider whether step 1 is good or not, or give it a score, and then evaluate step 2 and evaluate step 3. It is claimed to be that process reward model is better, working better, like helps better, giving you a much better solution compare with solution reward model. So what I would do is I will also scroll back into, we're very close. So I'm aware of the time, so I'll try to go through a process reward model and solution reward model as fast as possible. So what it does is like, we have steps by steps. We can ask it to generate step by step in one line. In one line. And then at some step, there might be a mistake. It's actually not, sorry, it's outcome reward model, not solution reward model. So outcome reward model, ORM. What it does is like, how does it evaluate the answer? If you're saying, okay, the max for this question, what is the result of the X? And it will consider the X to be 2, I think, maximum root. This is not. Oh, yes. So the result is 2. If you are giving the outcome reward model, it will evaluate these results. One of the methods I know people generally do is, first of all, if it's a math problem, you extract the integers or the values at the end and compare it with correct answer. If it's large language model, I know from the course actually I learned that you could also use large language model to evaluate it as well and give it score. But however, one of the cases is the X could be 1 in this case. If it's 1, it doesn't actually, it will result in 0 over 0, and the final answer is still correct, but we don't need to consider X equals 1 in this context. So in this case, that's the beneficial about process reward models, to evaluate each steps. So how do you define the solution steps? One way to actually ask it to generate step, like you can ask the large language model to generate step by step, and each step is a fresh line. Split your solution into individual logical steps and keep each step in one line. You can also ask it to evaluate the partial solution as well. Like I can evaluate step 1, I can evaluate step 1 plus 2. So why are we using this? Like, why are we evaluating partial solution? It was because sometimes we do not need to consider sometimes we do not need to evaluate the whole step. Let me go back to this figure graph. Let's graph of thought. So graph of thought. So in generative reasoning model, we need to explore all these little circles to find out the best result. But what could be done was we are evaluating process reward. After these three, the first step, I'm saying that, okay, the second step, maybe this is not a good example, but like after the first step, okay, I'm having this step, which is not very good, has a very low score. I'm just going to abandon it immediately. And I'm comparing these two, I'm choosing the top two, and then the second step, I'm evaluating these steps and evaluating 1+ to step 1+2, which have a higher score. And then I can probably abandon a few branches already before I explore more, because otherwise it's going to be quite computing expensive. So this is one of the applications with a process reward model. And if there is no ready-made data set available, how do we actually generate data set with the step by step to find out, okay, can I create a training task, or I don't have this training task? How do I know which step is better? So basically, we generate a large number of continuation and check how many of them arrive at the correct answer. Sorry, how many of them have the correct answer, and that also answers kind of a part of the reason of how do they choose the best answer is like math problem. Is the training data set or the data set they use to evaluate how good they perform. Over here, if they get the math answer, like they are kind of mixed up, like I generate I generate step 1 with 3 different answers. And then from each of them, I generate steps 2 with different answers, and I mix them up to see which one gives me the right answer. And in this case, I know roughly about, okay, the combination of which and which would give me a better result. From the ratio of correct answer, we know roughly, okay, which process give how many scores. This is during the training process. So yes, and I think we have gone through the majority of it with nonlinear reasoning. And we are also considering having an in-person study group if you guys are interested. One thing I want to remind you guys, if you're not in the Slack channel, I would encourage you to actually get into the Slack channel because we share everything in the, we share all the links, including if we're asking people about when do you want to have this in-person study group to actually start code together. Then we basically ask them in the channel. So if you haven't been into the Slack channel, get into our Slack group, and we are in large language model LLM engineering study group. Okay, before I finish this, does anyone have any questions? Like, it doesn't have to be technical questions. Like, just one reminder, we have the cohort, the official Nebius cohort tomorrow. I think tomorrow's session, it might be a little bit different. It might be, I saw the news, it says that they are going to, it's actually a webinar about image generation by Roman Savarov, ML engineer at Retrieval-Augmented AI. So don't forget, our study group is running in parallel with them, trying to actually basically finish their course. So any questions? Okay. No, thank you everyone for joining. Hope you all have a very good Tuesday evening when the sun is still out there, or maybe not if you're in a different country. All right. Thank you, everyone. Thank you. See you. Oh, I need to presenting. Thank you.